So this is part of exponential growth and decay, but it's specifically Newton's laws of cooling. Just to make it easier, I think we're going to screenshot this and we'll just paste it onto here. It'll be easy to work with. All right. So, like I said, these ones here are pretty standard questions. So whatever you work on in your textbooks or with me are the questions that will be asked in your exams. And they usually are worded like this. So the rate at which a body cools in air is proportional to the difference between its temperature and the constant temperature A of the surrounding air. This can be expressed by the differential equation dT, standing for temperature, on dt, time. So that's time and that's temp, is equal to K, the proportionality, multiplied by the difference between its temperature, so T minus A, which we know is a common, that is Newton's laws of cooling, so that must happen, where K is a constant. Show that T equals A plus BEKT is a solution of the differential equation. For it to be a solution, the integral of this must equal to this, or the derivative of this must equal to this term right here. So the easiest way is we're going to differentiate the derivative of this term with respect to time. So A is just the constant, that's gone. You're left with BEKT. What do we do when we're differentiating BEKT? We differentiate the KT, which becomes K, and then exponentials are always exponential, so that doesn't change. And then if you remember, your constants that are multiplied at the front, that are multiplied, are still going to be there. Okay, anybody not sure what I've done there? Please, you've got to make sure right now you ask me. Do we know how to differentiate exponentials fully, like the way I just did it? So E becomes E, that doesn't change, the power doesn't change. The way we differentiate the power, which is K, because you differentiate with respect to T, so K, and then you multiply K, and then B, EKT, or BK, EKT. All right, any questions? Okay, you're trying to get K bracket T minus A. Of course, I think you guys can see, if you did T minus A, that is BEKT. So BEKT is obviously, therefore T equals A plus BEKT is a solution to the differential equation, or of the differential equation, Straightforward, 1 mark. Very, very easy, 1 mark. B, because you're an extension 1 student, this part B is not going to be broken down like it was in exponential growth and decay, where, you know, it had part B, do this, part C, do this, part D, do this. As an extension 1 student, your B is just going to be all of B, C, and D together. So you're going to do the whole lot yourself. The first thing you're going to start with is the equation. I think we understand. Usually we want it to be in this form. You know, you want A to have a number. You want B to have a number. You want K to be a number. And then I'm just going to say, okay, what's the temperature when time is 5? Well, sweet, you're just going to make that into 5. What is the temperature when time is 10? You're going to be like, oh, yep, I've already got my formula, so now that's 10. What is the time when temperature is 100? Well, you're going to be like, yep, just make that into 100, and so on, and then solve for T. So the logic to your questions is to always start with your equation and then solve for A, B, and K according to the question, according to obviously what the question's saying. Once you find your A, B, and K, you'll have an expression here that relates T, temperature, with time, and then you can pretty much finish off the question, whatever it's asking to do. So let's read. Let's not confuse us, and I'll cross that out just like that so we know that's not part of it. A heated body cools from 80 to 40 degrees in 3 hours. Okay, so then when time is 0, what do I know the temperature to be? Compared to when time is 3, what do I know the temperature to be?
Temperature would be 80 when time's 0 and 40 when it's 3.
Perfect. That's it. That's a heated body cools from 80. That means you always got to have initial. So always time equals 0. That's obviously when temperature's 80, and then in 3 hours it's dropped down to 40 degrees. So you know the temperature is 40. The air temperature around the body is 15. Air temperature, A. Air temperature. So A equals 15. And then find the temperature of the body after a further hour has elapsed. So find temperature when time equals 4 after another hour. So you can't do this yet. That's what I'm trying to say, right? We've got to first get our expression. Once we've got our expression, then we can obviously, how easy would that be? Just sub in time is 4. So let's do it. The first step is your first piece of information. Okay, so when time equals 0, T equals 80. Let's put that in. T is 80. We know A is 15 plus B, we're not sure what that is. E, K times 0 is 0. We know by now E to the 0 is what? What's E to the power of 0 going to equal to?
1.
1. So that's 1. And then obviously you've just got B there. Take away 15. B equals 65. Simple. Now you've got a new expression. Your expression is what? T equals 15 plus B E K T. You're like, got to get rid of the K. But you've got another piece of information. When time is temperature is 40, time is 3, temperature is 40, time is 3. Obviously, you're going to solve for K this time. The way we do it, we'll subtract 15 first. So 40 take away 15, 25 equals 65, E 3K. I don't like the 65. You would divide it. 25 on 65 becomes 5 on 13. What do you do now up to both sides? You don't like the E.
ln.
ln both sides. Log of this, keep it the same. When you've logged, you're allowed to bring your powers down. That's the logic. And then log E cancels out, but I thought I'll just write it just to remind you guys that's what you're doing. So the 3, you technically got this, right? And then with logs, if you remember your laws, it says you can bring this down. So technically, that's what you're getting. And then obviously log E cancels out. That's the whole point of why you logged in the first place. So if you don't write it, that's fine, but I just thought I'll show it again, what we're doing. Divide by 3, and you're done. So K equals log 5 on 13 divided by 3 equals, let's do it in our calculator. So log answer divided by 3, K equals negative 0.3185. Now, what I press now is Shift, Store, A. Reason why I want you guys to get used to that, because you don't use a rounded answer. This has been rounded. Now, obviously, I'm rounding to 4 dp, 4 decimal places. If you do that, you generally don't have a problem. But as we get to harder and harder questions like in Year 12, when we're not just going to deal with exponentials, we're going to start dealing with trig, exactly the same questions, but with trig. It's going to be annoying because you have degrees, radians, blah, blah, blah. So to avoid that, we're just going to store our answer. If you learn to store it, we should be fine. So you can write this, but you use this one, the actual answer, which is going to be this term. Okay, so now we've got our final equation. It is T equals 15 plus 65 E negative 0.3185 T. And obviously the question just said, find the temperature when time is 4. So temperature equals 15 plus 65 E negative 0.3185 times 4. I'm going to use my actual A for this, right? Just so you guys know. 15 plus 65 E, my capital A times 4. I got temperature is 33.18 degrees. Does it say to the nearest whole number? Go back. There it is. Nearest degree equals 33 degrees. This is worth 3 marks, but it is 3 marks of something you already know what to do, right? It's not 3 marks of, oh, well, this is a hard question and it's worth 3 marks. It's, I already know I'm going to start with that expression all the time. I've always got to find my initial point. Then once I've done that, I sub it back in. I'll solve for k, second condition, solve for k. Once I've solved for k, I now have an expression with time and temperature, and then whatever they wanted to find. Time, that means you're solving for time, so they'll give you temperature, or if you're solving for temperature, they will give you time. All right, any questions? You must be able to execute that. So my tip to you would be, after today's lesson, maybe the last 10 minutes or 20 minutes, around 12 o'clock, just go back and try to execute this yourself. Just this exact question, because that's 3 marks, plus the 1 mark at the beginning, 4 marks. You can walk into your exam confident to get at least 4 marks. Easy 4 marks. There's really no reason why anyone should get this wrong. You're just copying the same thing over and over again. Okay. Any questions before I move on?
Sam, so when
Yes.
you're solving for B and K, you use the final values, so 3 and 40.
Say that again. So to solve for B
and K,
it looks
we have to use the final values, right?
I don't know what you mean by the final values.
Because you use 3 and 40.
I use 3 and 40 after I use 0 and 80.
So it doesn't matter which one you use, right? Like, as long as they're the same.
Well, okay. So if I had chosen 3 and 40 first, I would have still had a problem with not having B here.
Okay.
Right. So when you're going to do 3 and 40, you're going to be missing B and you're going to be missing K.
Yeah.
So the trick usually is, don't do your second set of conditions until you've done your initial conditions. And the reason why you would do that is because when time is 0, it's going to eliminate the K value.
Yeah.
So it doesn't matter. It's just that when you do it here, you will have 2 missing letters. So then you would have to, once you've written this, you probably have to stop, go back and find B first, and then go back again and solve for K.
All
Does
right.
that answer your question?
Yeah.
And then, yeah, once you've used your 2 conditions, that would find you B and K, always. And then you would have A. A is going to be given to you because that's constant air temperature. So that's just in the question all the time. And then, yeah, and then just a matter of solving, really. Do we want to do one more? Or we feel like that's okay? Because it's going to be exactly the same. I wouldn't do anything differently. So it's either do one more, or you guys are going to do it at your own time and try to memorize every single step. Pretty much try to execute this exact question. You might get stuck somewhere here. That's fine. Look at it. Look at one more line and then try to do the rest. You might get stuck in this line. Look at it and then try to do the rest yourself. So what do we want to do? One more or move on? Quiet means okay, we're okay to just memorize. See, exactly the same. Exactly the same. Exactly the same. It's just that I changed the expression just to annoy you a little bit, but it's exactly the same math. I gave you A, I gave you A, I gave you B, I gave you everything. It's just that you got to find K. And the way you're going to find K is, I said initially there was only 1 rabbit infected. So that means when time is 0, N is equal to 1, and then you're just going to solve for it. So it's exactly the same. It's just I changed the expression just to be a bit annoying, but simple stuff. Okay, let's do rates of change. Now, this one here, I can't say the same thing. I can't say, hey, just go and memorize this and you'll be fine. because you won't be. I can't say, hey, go memorize this one and you'll be fine, because you won't be, right? So this one here, you really have to give it time. A lot of exposure, a lot of questions. So I think I might start, let me see. Yeah, we're going to do this one. Okay, we'll start off with this. So further rates of change. So a few things we've got to understand before I can actually do these questions. And I will show you what they don't teach you, which is how I would actually look at this question and know what to do by just looking at it. Let's talk about rate. So by now, we've done y dash and f dash of x. And what's the other one that starts with d? How would you write that one? dy on dx. Now, these are all called, I mean, we call them gradients or gradient functions, which are absolutely correct. But as you get, that's only specific for like curves. As you get into application questions, we don't really call them gradients. We call them a rate of change. These are actually called rates of change. It is the rate that y is changing with respect to x. So that is the rate that y is changing with respect to x. So it's in terms of x's. So as x changes, y changes. That's the idea. And you know that's true because rise over run, when you do rise over run, it is the change in your y value with respect to the change of your x values. So if this was in midair, it's the change in your y values. This could have been 10. This was 3. That means your change in your y values is 7. And then this could have been 10 and this could have been 2. The change in your x values is 8. So your rate is 7 over 8. Your y values are increasing. Your gradient is changing 7 over 8. You can hopefully, I'm linking everything together now. You guys are starting to see how this is all working out. Another application that you're probably used to is speed. Speed is the most common one you're probably used to is 40 kilometers per hour. Well, speed is equal to 40 kilometers per hour. Isn't that distance over time? So then wouldn't this also be a rate of change? It is the rate that, what is changing? The rate that distance is changing with respect to what? Time. Right? Isn't speed just the change in distance with respect to time? So if you get 40 kilometers per hour or 40 kilometers hour, that's the same thing, that's just using index laws. These are actually derivatives. You just never saw them like that, right? These are distance over time, but they're actually rates of change, which means they're derivatives. So the derivative of speed is actually the derivative of x on derivative of time. The change in your displacement, the distance, over the change in your time. Anybody confused? I mean, some of the physics kids might get this a little bit easier because they look at this stuff. Others, do we understand that? I'll try to make it as simple as I can there. Do we get that? Fully? 100%. Kilometers is really important to bring this into this, because that is the trick. That's what I do. It's what you're not taught to do, but that is the trick to the questions. So let me look at another one. If I told you that I'm pouring That's a cup, right? And then there's water that's going in. And the water that's going in is 0.48. It covers 0.48 square meters per second. What would this be? What would this rate be? How would you describe this rate? It's the rate of change of what? What's changing? And with respect to what? Just take a guess. Does someone? Anouk, do you want to take a guess?
Well, it's going to be d something over d time.
It is. At least you know that. That's perfect. You need to know that. That's super important. So it is d something over d.
I thought it was volume over time initially, but you can't do that with meters squared.
Correct. You had it almost right. He said it's volume. What would you have written here if it was volume? What would I have
cubed?
Yes, this would have been cubed, right? That's the giveaway. There, you would have said dv on dt. Of course, if it's meters squared, you're going to say it's d.
Surface area?
You don't need to say s. It's just too hard. Like dA. One letter. Just, so that it's the area that's changing with respect to time. In fact, I've got a... Oh, it's not on this laptop. All right. Next week, I'll show you something cool. I created something for a different class, for a different school, a few years ago, where I actually make this water thing go in. And you guys can see what's happening, but I can just, do it right now without it being animated. So look at this, 0.48 meters squared per second. Each second, it's covering 0.48 meters squared. So obviously, you understand that the rate is the area is changing as time is changing. So 1 second it's up to here, 2 seconds it's up to here, 3 seconds it's here, 4 seconds it's there, and so on. So the way we interpret that though is this. Super important to understand it's a dA on dt from now on. So any rate you see, any rate for the rest of your life from today onwards, you think of it as a derivative. Okay, I hope that's clear. Anyone have any questions for me? Done. If we can do that, then maybe I just made the hardest topic really easy. So let's read. Oh, before we start as well. Okay, we need to know one more thing. They call this chain rule. I just call it basic algebra, right? They call this chain rule at your school. I don't like to confuse chain rule with the chain rule that we've done, u-v plus v-u. So I just call this basic algebra manipulation, but basic algebra pretty much. So watch this. If I've got dy on dx, right? If I want to rewrite that into something like this, what must these two be?
1.
So say it again.
1.
Okay. What if there were 2?
Then you'll have 2 dy. Oh yeah, that'll still work.
You can cancel it.
Okay, what if it was 20? Would it work?
Yeah.
Okay, so then what did you just realize they need to be?
The same number.
All right. So as long as they're the same, hey, why can't we just write it like this?
That's what I meant by 1.
Yeah. So d, let's say if we call the dA, hey, they just cancel out. So it's actually allowed. So they'll call this chain rule because it is, but to not confuse you guys, you don't need to worry about it. You just think of it as basic algebra. Dy on dx can be written as dy on something times that same something on dx. That's really important because that's the bit we're going to need, obviously, to execute these questions. Just an extension to it is if you don't have dy on dA for any reason, then you can also split that up. Of course, right? dy on dA can be written as dy on dt times dt on dA. Obviously a dt, but then now imagine you had dy on dt, you had dt on dA. Well, that just solves this problem. Times by dA on dx, then you eventually work out dy on dx. Okay, so let's have a look at this all applied in a question. Please You have to stop me if something gets confusing here. Let's start. The rate, I already know I'm going to think about D. The rate of increase of a circle's radius is 0.2 meters per second. So what should it be? D what? 0.2 meters per second. Radius. I'm going to choose X. X being for distance. Or you could have chosen R. dx on dt equals what? 0.2 meters. So when I say meters per second, I'm already thinking difference in displacement or distance over difference in time. That's time. So there it is. Do you guys get that? Because that's going to be step one. Step one. Do we understand that? Every question, you're going to be given that. You just got to realize it's that. Rate gives it away. To me, I don't like to just say the rate. This gives it away. I just look at that. I know that's a rate straight away. At what rate is its area increasing when the radius is 1.5? Okay, what am I trying to find? Actually, I might change this to R. It might be a bit easier for us, I think. Make that R. It doesn't really matter what letter you pick, but I think for the first question, it might be easier. Part 2. Part 1, given. Part 2, according to the question. At what rate is its area increasing when the radius? Okay, what do I write? Rate, area. D.
R on dA.
Oh, yeah, go wait, say it again. D.
R on dA.
Okay, good try. Good try. dr on dA. You've just found, just so you understand, you've just said, let me find the change in the radius with respect to the change in the area.
Oh, so how would you write rate?
But wait, yeah, good. I like that you said that. Rate. Now, rate is all of these. These are all rates, right? Technically.
Yep.
These are all rates. The rate that they're going to be talking about mainly is with respect to time. So when we're saying rate, we're talking about in terms of time, as time is changing.
Okay.
But what you had said was rate, right? Just so you get this. That is a rate. That's a rate that the radius is changing with area changing, which you know doesn't really make sense. It's the other way around, isn't it? It should be more as the area changes as the radius changes.
Yeah.
Yeah, but that's fine. That's easy to fix. You just flip it. You know, that's not a problem. But so, what should this on top be now? If you now know it's area, dA on dt.
Yeah. Yeah, that's the one.
Well, what would you write it as? dA on
Times something on dt.
Correct. And then what do you think that something should be? You go back.
0.2.
No. You go back. You see how it says dr? That's going to be dr. That's going
Oh,
to be
and then dr. Okay. Yeah.
That's the logic. All right, I'm going to pause there. Because that's it. That's the hardest step. Step 1, step 2. Everything else is going to be easy. You guys will get it. For every question, it's going to be step 1, step 2. So let's recap. Step 1, given. You know, you just got to learn to interpret it. 0.2 meters per second. There it is, dr on dt. Step 2, what is that saying? It's saying find the rate of area. Don't read into it too much. Area. Okay, so then therefore dA on dt. Then I now know it's dA on something times dt. Okay, but what letter do I pick here? Well, they gave me R, so I'm going to pick R. Now, can you guys see, look, dr on dt. I have that. That's 0.2. A and R, I don't have that. So I don't have dA on dr. But do you guys know a relationship now? Relationship between A and R? Do you have a relationship between A and R for this?
They're proportional.
Ooh, don't say that. Don't make it harder than A, relationship between A and R. Simpler, a lot simpler, and it's a circle. A
equals pi r squared.
That's all. There's your relationship. A equals pi r squared. Now, so once you've found your relationship, which is obviously easy to identify, you go dA on dr. You're differentiating A with respect to R. And Novak, I think last week you asked me, hey, can we just do A dash? And
Yeah.
that's why we don't, because like here, this you would write, oh, what's this? R dash and A dash, and it just doesn't work.
Yeah, it
So it's
wouldn't make
really
sense.
important
Yeah.
to know the order. So this is A with respect to R. And of course, what's the answer to this one when you differentiate it?
2 pi r.
2 pi r, which is, hey, circumference. You guys just proved circumference. And that is the change in area with respect to the change in radius. But anyways, 2 pi r. So now you know what dA on dr is. It gave you the radius is 1.5. I think we know what we're going to do, right? Equals 2 times pi times 1.5, which is what? 3 pi. So dA on dt equals dA on dr, which is 3 pi, times dr on dt, 0.2, and you're done. Okay. Questions? I don't like to write it in decimals if I don't have to, so that's exact. And take a look at that. I might scroll up a bit so you guys can see the full question. And girls, ask me any questions. Emily, Queenie, Nala, Shania, any questions? What do we not get, or what do we really get? That's the question you've got to be asking yourself. And what you don't get, clarify it with me. Be like, okay, how come this worked? Or how come you did this? Why did you do this? How did you know to do this? Any questions?
I think I'm
Yeah.
confused of how you got the relationship between A and R.
Yep. So just from this step here to this step here.
Yeah.
Yep, that's fine. So the way that will come as you learn to look into more and more questions. But the way I would look at it is, you're thinking of A, you're thinking of R. So you're thinking of area, and you're thinking of radius, and you're thinking of a circle. So what's the only relationship you have between area, radius, and a circle? Well, it's the actual area of a circle, which is A equals pi r squared. So if I gave you another question, I said, hey, okay, if I gave you another question and I did this, right, and I said R and H and 10, what's the only relationship you can have between the radius and the height in this particular triangle? What would you use?
Pythagoras.
Pythag. Yeah, and that would be a relationship between R and H. So now you know that R squared equals 100 minus H squared. R equals plus minus root. But you know it can't be negative because radius can't be negative. And then, see, you just found a relation between the radius and height of a cylinder, let's say. What's another one? If I did give you a cylinder, and I said exactly the same question, you found it up to dA on dr, but it was a cylinder. What's the surface area of a cylinder? Area of a cylinder is 2 pi r squared plus 2 pi r h. What's the problem though? Is that a relationship between just A and R? No, because you have H. And that's when you would use that Pythagoras question, bring H in, and so on. Do you get the idea how, like, it'll say shape, or say something, and then you'll know how to link them together. Either A and R or A and H or whatever is required.
Yeah,
so
thank you.
That kind of will be given. You're welcome, but that will kind of be given, and it's just, you'll see it. As we do the questions, you'll start to realize, okay, it's that shape, or it's that thing. And yeah, you'll get it. It's not always going to be a shape, so I can't just say it's a shape, but you'll see the letters. You'll start to link the letters together, but that's fine. Anybody else? Okay, let's have a look at another question then. Has anyone actually done rates of change at school yet? Okay, that's good. That's good. Bad, because it just means they're going to rush it when it's super important. Good, because at least I get to do it first and you can learn it our way. All right, we read again. The side length of a cube is increasing at a constant rate of 0.1 millimeters per second. All right, who wants to tell me what my step one? What am I going to write?
dl over dt.
Yeah, all right, fine. I'll use your L. Try to pick the one letter you like. Like me, I would have always used X's, right? It's just easier. But you want to use L, we use L. dl on dt equals what, Anouk?
0.1 millimeters per second.
Technically, yes. But we're more interested in the 0.1. At what rate is its volume increasing when its volume is 8 millimeters cubed? Okay, what do we write? What are we trying to find?
dv over dt.
Yeah, dv over dt. Andy, how would you write this? dv over what?
DE.
No, dv over?
DE.
Nah, you wouldn't write dv again.
DL. L.
dl, yep, that's it. dl. dl. So now you need a relationship between volume and your side length. Okay, Emily, do you have a relationship between volume and length of a cube?
I don't think so. I can't think of any.
Yeah, you're overthinking it. Isn't a volume of a cube just L times L times L?
Yeah, so it's L cubed.
L cubed. So V equals L cubed. There you go. That's your relationship. And then dV on dl, differentiate now with respect to L. That becomes 3L squared. And that's fine. The only problem is it's saying that you got to find it when the volume is 8. Now the other question was easy because it said, hey, radius is 1.5. So we got to this stage, we just subbed in 1.5. This one says the volume is 8. So I can't just sub it into here. Obviously, you would sub it into here to find L when volume is 8. So when volume is 8, it means the length is 2. That's what you would sub in. 3, 2 squared. 4 times 3 is 12. And then finish it off. 12 times 0.1. 1.2. Volume is increasing at 1.2 millimeters cubed per second. All right, girls, what do we think about this one? Makes more sense now? Finding it easy, Nada, yep, all good. Queenie, Shania, no problems? No, we're good. Yes, questions? Okay. Guys, what about you guys? All good as well? Any issues? All right. Hopefully I've made it easy. You can nobody can make it as easy as what I've just done it for you guys. You will see when your teachers do it. That is as easy as you're ever going to see this. So you're going to be given this. I stopped. There's a full stop. Write it down. Then this read it volume rate. So now you know it's dV on dt. Break it up into the 2 letters that you're given. And then, do you have a relationship? If yes, great, get it out. If not, if it's just partial, then we're going to have a look at those questions and we'll see what we've got to do. And then finish it off. And yeah, okay, let's do another one if there's no questions. Okay, let's have a read of this. The area of an equilateral triangle of side x is increasing at a rate of 5 centimeters squared per second. What do I write? D what?
dA over dt.
Good. You started to realize that. And how did you know it's again? dA over dt?
Yeah.
How did you know? How?
Oh, because it said area and it's saying rate per over time.
I would have more looked at, you're right, you're absolutely right, area and rate. I would have personally just looked at centimeters squared per second. To me, that's area over time. So then I think of dA over dt. That's my logic. However you're seeing it now is good. There we go. So now we know dA over dt equals 5. Okay, A. Show that the area of the triangle is given by this. Does not say anything to do with rate, so we're not doing anything, just the area of a triangle. Okay, equilateral. There it is. And each length is 60. What do I use to find the area? 60. Angle. How do I find area? Half
Base times height.
AB sine C.
Oh wait, never mind.
AB sine C. It's tempting to do base height, but I think pretty much from this year onwards, you're very rarely going to use base and height anymore. It's more going to be non-right angles, so yeah, half AB sine C. Half times x times sine 60. I think we can cheat. Sine 60 is root 3 on 2. Use your calculator to double check that. Therefore, you get root 3 x squared on 4. Any questions? Can we see that now you have a relationship between A and X? How nice of them. Part B. If they didn't, I can make this question harder by just giving you part B. You have to realize to find A and X when you get stuck in part B, right? Just so you know. So just keep doing it the way I keep saying it, which is find a relationship. After you've done this line, you find a relationship. But obviously a lot easier because we gave you A. Find the exact rate of increase of the side length when the triangle has side length 15. Okay, what are we trying to find? D what? I think now we know it's over dt. What are we trying to find? D what?
The side length, but
So
you
D,
said we can call that x.
that is it, dx. But they've even gave you side is x. So dx on dt equals dx on what, Anouk?
dA,
Yes. How did you know that?
because we used dA earlier.
That's it. That's the logic. You use dA on dt there, you use dA here. Now, dA on dt, easy, 5. Given, that's no problem. dx on dA, ooh, it's a little bit weird because we have A, we've got A equals root 3 on 4x squared. So I can't actually go find dx on dA because then you have to make x a subject. So the logic for this is it's still a relationship between A and X. You don't think of it in a different order. All you do is you find dA on dx. I think you guys can understand this. So 2 root 3 on 4x. Right, that's just a number, so just leave it. And then to find dx on dA, you just flip it, don't you? That makes sense. So 4 on 2 root 3x. And then 4 on 2 is obviously 2. Do you guys get that? So they gave me, I know I need dx on dA. But when I'm looking at my equation, I'm like, well, I'm only going to be writing dA on dx. But that's okay, I can just flip it. Yep, that makes sense. And then side length is 15. So that equals to 2 on root 3 times 15. So 2 on 15 root 3 times dA on dt, which is 5. And then 10 on 15 is 2 on 3. If you want to rationalize, you can. So 2 root 3 on 9. Whoop. 2 root 3 on 9. If you wanted to rationalize. Any questions?
Do we have to rationalize?
You don't have to. Don't have to. It's good to do it by now. You don't have to. All right. Any questions? And Nook, you seem to get it. Novak, Andy, what about you guys? All good with it as well?
Yeah, all good.
Girls, we're fine. We understood my logic for each question, how I stopped, how I thought about this, and how we flipped, and so on. Okay, it's good. Let's try another one. Let's try this one, and then I might move on, because that's it, right? Yep. I might move on and leave this one for homework for you guys to think about. Paste. Okay, let's try this one. A conical vessel is 40 centimeters in radius and 40 centimeters in depth. So R equals 40 and H equals to 40. And what shape is it? Cone.
It's like a cone.
Yeah. The vessel is being filled with liquid at a constant rate of 24 centimeters cubed per second. What is that equal to?
dV over dt.
dV, volume. The depth of the liquid at time t seconds is h centimeters. The depth of the liquid at time is h, obviously. What is the rate of, that's just saying when time is like 1 second, it's at, h centimeters. When it's 2 seconds, it's h again, because it's just different height. That's just obvious. What is the rate of increase of the surface area of the liquid when the depth is 15 centimeters? Okay, bit harder. So, Novak, surface area of a cone is obviously given to you. Novak, what are we trying to find? D what?
We have dV on dt. We're trying to find dr.
dA.
dA on dt.
Why did you say R? It says area. What is the rate of increase of surface area?
Oh, so dA on dt. Yeah.
dA on dt. Then, Andy, how do you break this up? dA on
dV.
dV. Now, what's the problem though? The relationship between area and volume. Do you have a relationship between area and volume?
E equals A times H.
Say that again.
E equals A times H.
V equals...
V equals a third AH.
Yeah. Third pi r squared h, you mean. But do we have a relationship between them? So is there a way that you could write, I don't know, area equals, I don't know, a third V? Let's say, is there a way that we could write something with A equals to something V's? Well, no, right? Because we know area of a cone is what? Pi r squared plus pi r L. We know volume of a cone is 1/3 pi r squared h. So there's no way these two will ever equal to each other or even be a part of each other. And then you've got two annoying things. You've got the fact that you're missing an L and you're missing a h here. So, because if I wanted to differentiate this, it would be with respect to r, and then differentiate this would be with respect to r. H and L, oh, we're going to get rid of that. So, this one, you can't actually do. You can't do dA on dV. So you're going to break it up. What are we going to break it up into? dA on what? What would these two letters be? Area with respect to what? And volume with respect to what? Say it again.
Time.
Time. So if you've got this, that means somehow You've got time. Somehow you've got to find a relationship between area and time. Do you have a relationship between area and time?
No.
No. So what should it be?
Should be L? Oh, no. Oh.
You could have done L, but that if you're going to do L, just think about my logic here. If you're going to do L, that's great. You can do dA on dL. You have to change your R's, which is harder to change 2 R's than compared to 1 L, but doesn't matter. Let's just say you found A in terms of L, right? We're just going to call it 50L for a second. That's great. You found dA on dL. But now you've got to do dV on dL as well, because this has got to be L. But do you even have L for volume?
No.
So L would not be right, and H wouldn't be right because you don't have H here either. So the only constants that are the same, or the only variables that are the same, sorry, are radius. So you would do dA on dr and dr on dV. Which means now I've got to get rid of L and I've got to get rid of height. Now, I know that the radius is 40, and so let's draw this cone real quick. The radius is 40, and the height is 40. What do we know? Well, we know if the radius is 40 and the height is 40, then at any point, like if I was here, you would also say that this would be the same as this. If it was here, this would be the same as this. In fact, now you can conclude that radius is equal to the height. If this is equal to 40 and this equals to 40, that means radius equals to height. That's the conclusion you make from there. So from here now, you've got this. You can start seeing where this is getting hard now. The thinking process, which is why I said exposure. L. To find L, well, you now have a triangle. This is L. This is R. This is H. But this is also R, because R equals to H. Therefore, L squared equals R squared plus R squared, which equals 2R squared. That means L is actually R root 2. Going back up here, that becomes pi R squared plus pi R times R is R squared root 2. I'm just going to pause there. Now that thinking obviously is because I know what to do. There's no way you guys would have done that today, but the idea is tomorrow, day after, as you keep looking at it, the same question, it will come. All the cone questions and most cylinder questions require this kind of thinking, and sphere questions. So cone, cylinder, spheres require this thinking, Pythag, and this style of thinking. Okay. Well, now that you've got R and R, V with R's, A with R's, we can actually go ahead and find dA on dr. So, dA on dr, I'll just write on the top, A equals to pi R squared plus pi R squared root 2, so that becomes 2 pi R. And this becomes 2 pi 2 root 2 pi R. It's easier to write like that. dV on dr, so volume equals 1/3 pi R cubed. That means dV on dr is equal to 3 times 1/3, which is gone, so pi R squared. Okay, now almost there. So you've got these values, you've got these values. It means you pretty much have this, dv on dt we already have from the question. We're about to finish off. The only thing is we've got to get rid of these r's. It says when depth is 15. We know when depth is 15, when h equals 15, well, r also equals 15 because we just proved that up here. When h is 15, r is 15. So dA on dt, this logic here, dA on dt is equal to dA on dr, which is this thing, 2 pi 15 plus 2 root 2 pi 15 multiplied by dr on dv, which is this flipped, 1 on pi 15 squared times by dv on dt, which was 24. Whoa, that's a serious question, right? What is the rate of increase? It doesn't say exact, so you can plug it all into your calculator and get an answer. But I'm pretty sure I made this so that it works out nicely, but you can just plug it into your calculator anyways. Whew. So I want to just go up. I'm sure there will be questions, but you don't even know where to start. And I hope that I made that clear with this topic. It's not going to be a fun topic. It's not going to be something you're just going to be like, yeah, I get. Whereas the other stuff, you can. Like, they're not hard. This one here, a lot of exposure. So if you want to come first in your class, this is the topic that you want to perfect, because you know the others are not going to do it. They're going to look at it just the same way you're looking at it now. Okay. Copy that down. Are there any specific questions about this? Let's have a look at a HSC question and see how we're going to find this one. Okay. Let's have a read of this. Okay. A ferry wharf consists of a floating pontoon linked to a jetty by a 4-meter long walkway. Let h meters be the difference in height between the top of the pontoon and the top of the jetty. And let x meters be the horizontal distance between the pontoon and the jetty. Okay. Find an expression for x in terms of h. What do you think we're going to do? And then find x in terms of h, so therefore x squared equals 16 minus h squared, and then you can't cancel this out, be careful. So it's just root 16 take away h squared. Yep. So you'll start to realize as they will repeat. The styles of questions will repeat. The way we think about it will repeat. It's just the questions themselves won't really repeat. When the top of the pontoon is 1 meter lower than the top of the jetty, the tide is rising at a rate of 0.3 meters per hour. When the top of the pontoon is 1 meter, the top of the pontoon is 1 meter lower than the top of the jetty. So when it's just about here, 1. Top of the pontoon. The tide is rising at a rate of 0.3 meters per hour. At what rate is the pontoon moving away from the jetty? Okay. At what rate is the pontoon moving away from the jetty? What are you trying to find? D what? What are we trying to find?
dx over dt.
And how did you know that?
Because it's moving away, so I just call that distance over time.
Moving away, but
Yeah.
not only distance. You got to use the letters they're using, right?
Yeah.
dx, moving away, x. Moving away would be this way, left and right. Good job. What do you think you would write dx on dt as? You might not be sure, but that's okay. What about this? The tide is rising at a rate of 0.3 meters per hour. What do you think that is? D what?
Oh, it's going to be dh over dt.
dh over dt. So therefore dx on dt equals?
Dx over dh. Yeah.
And then what's dx on dh? Well, that's just derivative of this, which equals to square. So, you guys, you see how was that okay? It seems like it's okay for you. I don't know. What about the rest of us? dx on dh equals half. Yeah, we're just differentiating, so that's power of a half. Bring it down. 16 minus h squared negative half times negative 2h. Chain rule times the derivative of the inside. So dx on dh is, negative h, 16 minus h squared negative half times dh on dt. dh on dt is 0.3 meters per hour. You obviously know we've got to get rid of h, and that's saying when the top of the pontoon is 1 meters lower than the top of the jetty, the tide is around what rate is the pontoon moving away? So h is 1 meters, because 1 meter lower than the jetty, the top. So when h is 1, and you finish it off. 15, 1 on root 15, so negative 1 on root 15 times 0.3, and done. Negative 0.077. Was that okay? Andy, how'd you find that?
Alright.
All right. What part are you still getting stuck on? Like, did you understand my logic of the fact that that would be dh on dt, and then this bit here needs to be broken down? Did you get that bit?
I don't get the part where it's dx on dh.
So you don't know why dx on dh?
Yeah.
But you know how to differentiate dx on dh, like you know how I differentiated it? So do you know how I differentiated it, firstly? Other than the fact that you're saying, I don't know how you got this, I'm saying, do you know how to differentiate, or is that what you're confused about? How to actually differentiate?
I'm not sure as well.
You're not sure? Okay. So the first one is to differentiate this, let's say. That's really important to understand. So according to chain rule, if we had something like that, the way we differentiate it is you bring the half down,
Yep.
you rewrite, you take away 1 from the power, you have to multiply by the derivative of the inside, which would be negative 1 in this case. So your answer becomes, I don't know, negative half 5 take away x, power of negative half. So same thing. Square root becomes power of a half. You bring the half down. You rewrite the inside. You take away 1 from the power, which becomes negative half. You multiply by the derivative of the inside.
Yeah.
And then I just rearranged it. So that's how we differentiate. This bit, why did we even write it as dH? It's because you've got dx on dt, right? You know you need to do that. Do you know that's what that was saying? Right?
Yeah.
It's moving away.
Yeah.
Then you're like, okay, you've got dx on, and then pretty much you got to think about what letter they gave you. They gave us h. Or another way is think about I even. I, you just found a relationship between x and
H.
h. So obviously it's going to be dx on dh and then dh on dt. So there's two ways to look at it. Either the fact that you found a relationship between x and h, or the fact that there's dh on dt given. And then, yeah, just a matter of plugging it all in.
Yep.
Sam,
Yeah.
when you're doing the chain rule step, shouldn't you wrote the derivative of 16 as x? Or was that a time? Oh, never mind. That's a time. Sorry.
No, sure? All good?
Yeah, I thought that time symbol was x.
T. Sorry. Okay. Let's look at another one. Andy, let's do it together from the beginning. Suppose that water is flowing into a large spherical balloon at a constant rate of 50 centimeters cubed per second. So what are you going to write, Andy? That is?
D. Centimeter. V. Oh yeah.
Why are you overthinking that? So wait, hold on. Let's just get that clear. If I write this quick, what do I write? D what?
A.
If I write this, what would you write?
A.
dA on dt.
Yeah.
What if I write this? Sorry, meters per second.
M.
M,
Wait.
meters per second. What are meters usually measured in? I don't know, you could have said length, or I usually just say x.
Ah. Okay.
Distance will be my x, instead of writing dd. I mean, that looks weird. So just write x. Again, centimeters per second. What would you write?
TX.
dx on dt. Okay, what about meters cubed per second? What would you write?
DV.
On dt. What if I said meters cubed per meter squared? What would you write now?
DV on DA.
All right, good. We get it. That's it. So don't make it hard for yourself. It's really meant to be that simple. So there it is. Centimeters cubed per second, d volume over tt. So that's given. Done. And you know what shape it is. It's a sphere. So at what rate is the radius increasing? Radius r increasing. What rate? Radius increasing, radius 7. Okay. So what are you trying to find? D what?
R.
Yes, on dt. You're going to break it up as dr on?
DV.
Correct. Now, dv on dt, given 50. Do you have a relationship between vr for a sphere? vr sphere. Well, what's the volume of a sphere? Not sure?
I don't remember.
Don't remember? Yeah, that's fine. 4 on 3 pi r cubed.
Yeah.
Then, how do I find dv on dr? Multiply it by 3. Differentiate, yeah?
Yeah.
Multiply by 3. So I get 4 pi r squared. Are you comfortable with that line?
Yeah.
Okay, but I needed dr on dv. So what are you going to do to this? One more time. I have dv on dr. I wanted dr on dv. Other way around. What are you going to do to this side here? To get dr on dv.
Times it.
Not times it.
Divide.
Yeah. What do you mean? What do you mean? What would you write? dr on dv equals? Again, look at it one more time. Make it easier for yourself. dv on dr, this fraction, is equal to 4 pi r squared. I've got the very similar fraction. It's just been flipped. So what would you do to this side?
Flip it.
You just flip it as well.
Uh,
Right, you're finding the reciprocal. Radius is 7, so then your answer is just 4 pi 7 squared times dv on dt, which is 50. And then you're done. Does that make sense?
yeah.
Okay. 49 times 4 pi. 0.08. For example, centimeters per second. So the radius is increasing at 0.08 centimeters per second as you fill up a balloon with water.
Yeah.
B. Okay. Queenie, let's try B. At what rate is the radius increasing when the volume is 4,500 centimeters cubed? Queenie, what am I trying to find? Rate, radius. What are we trying to find again?
dr.
Yeah, dr on dt. So you're still going to break that up into the same thing. dr on dv times dv on dt. You still have dv on dt, which is 50. The only difference is I gave you radius here, I gave you volume here. So when you're at this stage, dr on dv, you can't say you're done, because you're not. You're here 4 pi r squared, but you don't have the radius. You only know the volume. So how do I find the radius when the volume is 4,500?
You just
How are you
make
going to,
R
yeah.
the subject.
from this expression?
Yeah.
Yeah, that's it. So volume equals 4,500 pi, which equals to 4 on 3 pi r cubed. And she's right, just make r the subject. So get rid of the pi, times by 3, divide by 4. 4,500 times 3 divided by 4 is 3375, cube root that. Oh, works out nicely. R is 15. All right, I found that. What do I do now, Queenie?
You sub it back in.
So dr on dv equals 1 on
1 on 4 pi 15 squared.
times 50. dv on dt, which was 50. And you're done. That's another one done. Good job. So 900 pi reciprocal times 50. This one is 0.018 rounded. So now when the radius is larger, radius is 15, this was radius was 7. When the radius is larger, the radius is changing with respect to time smaller, which makes sense, doesn't it? I mean, if you think about a balloon, imagine right at the beginning, you've got a small balloon, right? Really horrible shaped balloon. You've got a really small balloon. The radius would be getting larger quicker at the beginning, and then once it's a really big balloon, right? Once it's a really big balloon, the radius won't be changing that much as you put more and more water in, right? Because it gets to its capacity and eventually it'll obviously explode. So it kind of does make sense as well, as it should, because we are applying this into the real world. C, Let's try C. What does C say? What should the flow rate be changed to so that when the radius is 7, it is increasing at 1 centimeters per second? So what should the flow rate be changed to? So what are we trying to find this time? So that is the radius is increasing at that. So what's this now? This is now dr on dt. What should the flow rate be changed to? What do you reckon? What are we trying to find? Flow rate.
dv on dt.
Oh, too good. dV, the volume, the flow rate is the water flowing in. So dV on dt. So this time you're trying to find dV on dt, which equals to dV on dr times dr on dt. You already have dr on dt. It's 1. We just need to find dV on dr, which we did up here. dV on dr is right there, 4 pi r squared. The radius is 7, so 4 pi r squared. That's it. It needs to be changed to 615. Sounds awfully large, but anyways. 615 centimeters cubed per second. So it needs to flow at that rate for it to be increasing at, so that the radius of 7 centimeters is increasing by 1 centimeters per second. Whereas here it was only increasing by 0.08. Yeah, that makes sense. So a lot more. Good. It seems like you're getting it, which is good as well. Good job on that. All right. Let's go again. How are we going for time? Yeah, we're looking good. CSSA. Let me see. All right, let's do it. So again, another question, another exam question. This was in the CSSA trials. And again, can you see it's a different question altogether? Because now it's got to do with the sector of a circle. So let's do it. A sector of a circle with center O and radius R is bounded by the radii OP and OQ and by the arc PQ. The angle POQ is theta radians. You know, it's always good to draw these out. Why not? Why would you not draw it? So there's O, there's P, there's Q. OP is radius, OQ is radius, your arc is PQ. Yes, the angle POQ is theta, which is what you would have assumed. The radius is R. And that's about it. That's all that's saying. Given that R and theta vary in such a way that the area of the sector has a constant value of 100 centimeters squared, such that the area of the sector has a constant value of 100 centimeters squared, show that theta is equal to 200 and R squared. Okay, so the area is always 100. That's not a rate, right? Why is that not a rate, you guys? Well, one, it's not changing, but what's the other giveaway? That it's not a rate. Novak? How would I have said that's not a rate? Other than the fact that it's obviously a constant. What's the giveaway here?
It doesn't have time.
Doesn't have centimeters squared per second, right? And it doesn't obviously say rate, but it doesn't say per second, whereas this one here, I think that's a typo, there should be second there. Centimeters per second, rate. That's how you know that is a rate. It's not a rate. So area is 100. All right, how do I find the area of a sector? What's the formula? Very easy. Pi r squared times
Theta
theta
over
on
360.
360. And then you know that A is 100, so the only problem is you're using theta radians, so therefore your 360 needs to be in terms of pies, right? So that should have actually been 2 pi. Should have really been 2 pi. And then what happens is your pi and pi cancels. So you're left with r squared theta on 2. And I think we can already tell the answer. Times it by 2, divide by r squared. You have a relationship between and, so you kind of know what's going to come up. Double I. Given also that the radius is increasing at a constant rate of this, so I now know that is dr on dt. Find the rate at which this is decreasing when this is happening. Finding d theta on dt, at which the angle is decreasing. D theta on dt is d theta on, obviously we now know it's dr. That's the giveaway. That's the second giveaway. D theta on dr. To do that, you know you can't differentiate powers on the bottom, so you're going to bring them up. D theta on dr is equal to negative 400 r negative 3. So that equals negative 400 on r cubed. Negative 400 on r cubed. Radius is 10. 10 cubed times dr on dt, which is 0.5. We can probably see the answer. It's negative 0.2. How was that? Getting easier? Different questions? Same concept. If you follow the way I've been saying it, it should work out nicely. Emily, what do you reckon? Getting better?
Yeah, it's okay. I just think the fact that like the amount of information, which like confuses me a bit, but it's okay.
I'm trying to cut the information off. I'm trying to say, yeah, don't read into it too much. If that's all that's saying, just draw it and then blah, 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 blah. Who cares? The area is constant, and then just to show that. Well, you know area, and then just do area of a sector. And we just do it, and it should just work out. And then same with this one. Given also the radius is increasing, all you care about when I'm reading this is radius, rate, 0.5. The rest, they've just got it right. And then I'm reading again, rate, angle, this. And the fact that it's decreasing, you can tell because it's a negative. We already know it's decreasing because it's a negative. It's increasing if it's a positive. So that's all the negative tells you, that it's decreasing. But yeah, I know what you're saying. Sand is being poured on top of a pile at a rate. So like this. Emily, what is that straight away now? 3 meters cubed per minute.
dv over dt.
Yeah, so you pretty much know kind of the formula is going to have something, and then eventually it's going to have a times dv on dt. You know, you kind of get to learn that. There you go, you have that. The pile always remains, so let's read it again. Sand is being poured onto the top of a pile at the rate of 3 meters cubed per minute. The pile always remains in the shape of a cone with semi-vertical angle 45 degrees. Find the rate at which the height is changing when the height is 2 meters. Okay, so wait. It's pouring into a cone. If it's pouring into a cone, you obviously know it's not going to look like this, or does it? Wait. No, I wouldn't have assumed so. I would have assumed it would have looked like this. Let me see. Yeah, you guys agree with that? When you're going to be pouring sand, it's very unlikely for it to shape up like this. It will most likely shape up like this. We understand that? So, first thing I would write or do, I would draw up my little cylinder, cone, sorry. Just so I can picture everything. Sand being poured at rate, the pile always remains the same with a semi-vertical angle of 45 degrees. So that means that right there, half of your vertical, angle 45 degrees. So that right there, 45 degrees. Find the rate at which the height is changing when the height is 2 meters. So the height, this is H, this is R. Now what else do you have? You've got L as well for a cone. You've got dV on dt. We want to find dH on dt. To find dH on dt, we've got to do it as dH on dV times dV on dt, because we were given dV on dt, right? Now I need a relationship between volume and height. Well, what's the volume formula for a cone?
I don't remember.
Well, actually, okay, what's the volume of a cylinder? Do you know the volume of a cylinder?
Like pi r squared plus 2 pi r,
Oh,
something
no,
like
that's
that.
area. That's area. So surface area is 2 pi r squared, so 2 circles plus your curved bit, 2 pi r h. Your volume of any shape that's not a pyramid is just one area of the base multiplied by depth. So pi r squared times by height. That's how you do all volumes that are prisms. Now if they're pyramids, you take the prisms and you multiply them by 1/3. Any pyramid. So if I have got a triangular pyramid, you just find a triangular prism. Imagine that with a prism. So it'll just be this area multiplied by depth, and then you just times it by 1/3. And that'll give you the pyramid. So same thing with of this is just 1/3 pi r squared h. Right? So now, what letter do I need to get rid of here to do dH on dV? Emily, what letter? Go into
You need to get rid of the r.
I need to get rid of the r. But then I look at this expression and I'm like, well, I can kind of have a relationship between r and h using using SOHCAHTOA. Yeah, or Pythag or whatever, but you don't want to bring L in, because once you're going to bring L in as well, that's just going to confuse everything. So tan is opposite over adjacent. Tan 45 is equal to opposite over adjacent. Therefore, tan 45 is 1. You just proved r is equal to h. Some students see it like that. Other students also see it that if that's 45, that's 45. Well, that's just isosceles. So that's the same question that I did from my booklet. See? R equals h as well. So now you guys have this formula. Pi h squared times h cubed. Do you understand that, Emily?
Yeah.
You aren't going to find dH on dV. You are going to find dV on dH, which is pi h squared. Then how would you write dH on dV?
You just flip it, don't you? So it comes 1 over pi h squared.
dV on dt was 3. H is 2. That's what it's saying. So that's the last thing you sub in. First you just deal with letters, and the last one is you just sub it in. 4 pi times 3. I think we can keep this one exact. You're done. 3 on 4 pi. Yay. So you'll learn, I think, to me, it looks like your hardest line is just the formulas of cones and stuff like that, which is simple Google. You'll learn them all again: surface area of a cone, cylinder, and spheres. But otherwise, yeah, we had to get rid of your radius. So that's where this is helpful, the diagram that I've drawn, and then just a matter of doing it really. Find the rate at which the base area is changing. Okay, just the base area. What's the base area? A, B. Oh, ran out of room. I can come up with. So the base area is obviously pi r squared of a cone. So we're just going to do dA on dt, but we've got to keep in mind that A is just the pi r squared. So dA on dt is equal to dA on, all right, and base area is changing, the height is 2 meters. So dA on, what would I use? You've got dV on dt. You wouldn't want to use dV, right, Sam? You probably would use dH on dt, what you just found. So I just found the height is changing at 3 on 4 pi. Yep, the height is changing as 3 on 4 pi. So I wouldn't use dA on dV. The reason why I wouldn't use that, because I know I don't have a relationship between area and volume. So there's no point of doing that. You've already found dH, you might as well use dH. So dH on dt is just 3 on 4 pi. dA on dH, well, area equals, we know that R is equal to H. The area of the base is what?
Pi r squared.
Pi r squared, but you know R is equal to H, so therefore area is also equal to pi H squared. And now you have a relationship between dA and dH, don't you? Which is just 2 pi H, height is 2, that becomes 4 pi, and you're done. So it's, yeah, a lot of exposure. A lot of exposure. I just didn't choose volume because I know I can't do area with volume. It was just going to be silly if I had written V. So I thought, why did they give me part A? They said to find the height. Well, I'm going to use the height then. That's just easier. He said we have used R. Of course you could have used R, but you wouldn't know what dr on dt is. But then because dH on dt is the same, you would assume dH on dt is the same as dr on dt. So you would have got the same answer still. Might leave that one for you guys to try. That looks good. That looks even better. But I think I'll come back to those, right? We will come back to those probably next week when we do a bit of revision. I've got to start introducing these ones. 2 chain problems, which we did. Yep, we did 2 chain problems. These ones are the ones that you got to break up. Setting your work out neatly is crucial, especially in this section. Do not risk confusing yourself with poor setting out. Use more than 1 chain where necessary. So you'll probably create a few so that you can get it out. So let's have a look at this. This was a 2015 Extension 1 trial, and unfortunately they were annoying and put in the multiple choice. Because it's in the multiple choice, it's only worth 1 mark, but as you guys know, it's probably worth 3 marks of working out. So, which is why when we do revision for our exams, you'll probably see me saying we're not going to do our multiple choice when we're doing our exams at the beginning, because worst case scenario you can just take a guess, whereas with your unseen questions, worst case scenario you can't write down anything if you haven't done the working out. So very unlikely for us to start with multiple choice first. It's not the right technique. Because even though the questions are multiple choice, it's in the multiple choice section, sorry, the questions themselves are not at that level. they are still like 3 marks or 4 marks, especially towards the end of the multiple choice questions. Okay, let's have a read. Shania, let's do this one together. So it's going to be a little bit of a longer one because you've got to break it up, but let's do it together. So let's have a read. The volume of a cube is increasing at a constant rate of 100 centimeters cubed per second. So what is that? D.
Sorry, you just broke up.
That's fine. Yeah.
Over 3.
That's it. At what rate is the total surface area of the cube increasing when the side length is? Okay, so what are we trying to find? D.
A.
Yep.
Over
Now.
dt.
And then split this up into something like this. But what's annoying about this?
There's a relationship with
Yeah, keep going.
There's no relationship between the area and the volume. It's like,
Yeah. Area and volume cube, not really. So what's the area of your cube? 6L squared. Or 6x squared. Just use x, it's a bit easier to write.
Yeah.
6x squared, right? Because it's a cube. It's got 6 sides.
Mm-hmm.
And then what's the volume of a cube?
X to the power, yeah.
X cubed. So you don't really have a relationship between A and V. You can't write A. You can rearrange and solve it, but you're not going to do that. So instead, you'll break up dA on dV as what? What should these two be? Take a guess. dA on?
dt.
Ooh.
No?
That means you need A and T. So you're close, but like you only need A and T. What have you done here? You found your expressions, and then you go on to eventually differentiate these. So it's going to be dA on
dx.
Yeah, because you have a relationship between A and X. So when you said like you're like, oh, this is bad because we don't have a relationship for a cube of area and volume. Well, same thing when you're saying T, I don't have a relationship between area and time.
Okay.
That's why they even gave you this one, volume and time. They need to give you that because you can't actually find that. All right, that's fine. So, yep, and then what's dA on dx now? What's dA on dx for this one?
Use differentiate.
Yep. So what's your answer?
12x.
And then what's your answer for dV on dx?
3x to the power of 2.
So then dA on dx is 12x. Oops. Times dx on dV, which would be this flipped.
Yep.
And then dV on dt, which is 100. You know what x is. It's saying the side length of the cube is 10. So it's just a matter of plugging it in now. Good job. What's the answer? Looks like it's like B or A, I think. 120 times 100 on. Oh, I was wrong. Looks like it's actually C. Yep, C. Job. That's what we mean by the two chains. So like you're going to have one and then you're going to have another one again within itself. But the way I like to think about it, because I mean, you're not going to know, right? In an exam, you're not going to say, oh yeah, that's a two chain problem. It's not going to work like that. You're just going to start it off the way we started, and then you're going to have a problem. You're going to have a problem, and then you're going to solve the problem by going, okay, no relation between area and volume for a cube. What is the area of a cube? What is the volume of a cube? Oh yeah, it's in terms of x's. Yep, let me just make x. dA on dx, dx on dv, split that up, and then, yeah. Questions there?
No.
All right, awesome. Very good, very good. All right, Nada, can we do this one together?
Yeah.
Let's try it. Have a read. A spherical bubble is expanding so that its volume increases at the constant rate of, I'm pretty sure that was meant to be cubed, so we'll just adjust it for them. A spherical bubble is expanding so that its volume increases at a constant rate of 70 millimeters cubed per second. What is the rate of increase of its surface area when the radius is 10? All right. Again,
dv over dt.
what is that equal to? Yep.
Sorry?
dV over dt. What? Yep, that's correct. What are we trying to find? Rate of area. D what?
dv over dA.
Wait.
Oh wait, dA over
Over.
dt.
Yes, that's correct. And then that's broken up into
dv
dA
dA over dv.
times dV over dt. Right? Because then these two have to cancel out, don't they?
Yeah.
And then the same problem. We're looking at a sphere. Right? For a sphere, do we have a relationship between area and volume? You'd probably be like, not really. But what do I know if the area of a sphere is? And what do I know the volume of a sphere is? Do you know them?
Pi r squared.
4 pi r squared.
4 pi r squared.
So 4 circles in a sphere. 4
And
pi r
then
squared.
4 over 3 pi r.
Cubed. Perfect. Okay. So then, once you know this, you pretty much know how you're going to split this guy up. dA on dV is going to get split up again as what? What are you going to split this guy up into? dA on dr. And then dr on dV times dV on dt. Beautiful. And then pretty much just a matter of differentiating now, isn't it? dA on dr, 8 pi r, dV on dr, times it by 3 becomes 4 pi r squared. dA on dr is 8 pi r, the radius is 10. All right, now all good with everything?
Yeah.
Yeah, done 4 pi radius squared times dV on dt. dV on dt is 70. And that's the answer. 14 millimeters squared per second. Good. I hope this is getting even easier as we keep going through it. Any questions? Andy, any questions?
No.
Well, it's starting to make a lot more sense now?
Yep.
All right. Good. Good. So it feels like there's no structure, but there actually is. You know, the fact that I gave you dV on dt, that already tells me I now know what these two letters are. Then I'm like, well, the fact that it's saying find the surface area, I'm like, yep, I already know that means dA on dt. And then I'm like, okay, there's no relationship. So then what is a relationship between sphere, area, and volume? Oh yeah, that's just area equals and volume equals. And then split this up and so on. So there is structure. It's just that you've got to start to realize there's structure. Okay, I'm happy. You guys are killing it. Okay, purely algebraic, not today. That's next week, once we do a revision. I think that's done. So purely algebraic is just, there's no numbers. It's going to be a whole lot of letters. So you just got to be really strong at the basics to get that. So I might not start that just yet. I might close that now. I don't need that for the rest of today. I've sent this Norman Hurst booklet to you guys already last week. I will send this one now. I'll just see if we can find any more. I'll leave that one for you guys to try. Population growth and decay. So now look how easy these growth and decay questions are. Here's a HSC question. According to the model, here's the model. According to the model, how many birds were there when observations began? What do we let time equal to? 0. Plug it in. It's probably going to be 450 because that's e to 0 is 1. 1 times 300 plus 150 is 450. 1 month. According to the model, what will be the rate of change in the bird population 10 years after observations began? So what does that mean? Differentiate, right? Rate of change. So you differentiate and then you sub in. Time is 10. Marks. What does the model predict will be the limiting value of the bird population? Anyone understand what it means by the limiting value? So what it would eventually be. What does that mean in terms of time? What is time equal to? Eventually. Without even reading the question, I just want to see if you guys can understand how these ones are all the same. But yeah, any ideas of the limiting bit? Take a guess. What does the model, Queenie, what do you reckon? What does the model predict will be the limiting value of the bird population? So it's saying, what would time be firstly? You're trying to find the population when? When time is what? No idea. Novak, any ideas?
I'm not sure.
Novak? Anouk?
No.
Eventually. If I came up to you and I said eventually, you would say time equals? And I say, hey, it's worth $1 million. You're not going to not answer. What are you going to say? Queenie, what would you say now? It's worth $1 million to you. I come up here and say, hey, I'll give you $1 million. Just tell me what would time be eventually? And you'll say, okay, you'll think about it.
0.
You'll say 0. Eventually, time is 0 means at the beginning. That's the beginning.
Infinite.
Yeah. That's what I would say. Eventually, you're like, oh, well, you don't know if it's 1, 2, 3, but eventually means forever at the end, like the maximum I could get would be infinity, when time is infinity. See, now you'll get $1 million. It's funny. Think of it like that in an exam instead of, or any questions you see, instead of quickly jumping into, oh, I don't know, or I can't do it, just be like, okay, gotta really think about this. And if it's worth $1 million, you will think. You won't just go, I can't do it. So anyways, time is infinity. What's e to the power of negative infinity? What does that become? What happens to your exponential as it approaches negative infinity?
It approaches 0.
It approaches 0. So 0 times 300 is 0. The maximum population you're going to have for your birds are 150. That's it. You can't get more than that, according to this model that they've created. So if you ever see limiting value, that just means eventually, like what's the maximum limit? Like you can't get past that, which is when time approaches infinity. And then the species will become eligible for inclusion in endangered species when it falls below 200. When does the model predict? It just says now P is 200, go and solve for time, which we might as well do. But like these are really easy compared to those other rates of change. I just want to show you guys, these ones are a lot easier. So subtract 150, you know, divide 300, log both sides, and then divide by negative 0.05. And that gives you the time. And but it does say when does the model predict. If you just found the time, it won't be right. You know, it started in 2000 and, oh no, it doesn't say when it started. Okay, then it'll be fine in this case. If it started in 2004, let's say you found the time was 10, you've got to say it's 2014. In this case, it just says when does the model predict. Your time is fine. You'll say in the 30th year or in the 10th year or whatever it is. All right. I am